Today we are going to talk about piecewise functions. So you will be able to graph piecewise functions, including step functions and an absolute value function. So what even is a piecewise function? A piecewise function has different rules for different parts of its domain. So we're going to have restrictions and special directions for different parts of our domain. In our first example, we have the absolute value function. And we know that when we're taking the absolute value of a positive integer is itself, where the absolute value of a negative number is the opposite of itself. So we are going to graph this. What I like to do is look at our domain, and our domain is located here. These are our specific parts of our domain because we are doing two different things when x is greater than or equal to 0 and when x is less than 0. So when since we're splitting at 0, I like to draw just a little line at 0, at x equals 0, because I know two different things are going to be happening on both sides of this yellow line. The first one I'm going to look at is when x is greater than or equal to 0, we are going to be equal to itself, x. So, if I was to make a table of values, for that side, I'm going to start at my fence so I know where I'm starting. So 0 is equal to 0. So 0, 0 is my first point. Then I'm going to do 1, 1, and so on. It goes to 2, 2, 3, 3, and I have graphed the line y equals x. Then for any x values less than 0, we are going to do y is equal to negative x. So once again, we can make our table of values. I'm going to see where I would start on my fence. So 0 is negative 0. So 0, 0. We're starting at 0, 0, but the point isn't actually on this side of our fence, but that's where we're going to connect to. Then I'm going to go to negative 1, and the opposite of negative 1 is 1. So I'm going to go negative 1, 1. And so on, continuing the line y equals negative x. Negative 2, 2, negative 3, 3. I'm going to erase this yellow fence that I made because that's not really part of my graph. It's just to show me where I'm separating my domains. But I have now graphed my absolute value function. Step functions are also examples of piecewise functions. A step function pairs every number in the interval with a single value. So, the graph of a step function can literally look like steps of a staircase. An example of a step function is called the greatest integer function. And the greatest integer function represents the greatest integer less than or equal to that x value. So, we are going to look at the graph of f of x is equal to the greatest integer function. And here we have each piece of our graph is a horizontal segment, but is missing its right endpoint. And the reason this is still a function is because that open circle indicates that that right endpoint isn't part of the graph. But there is a point right above each of those endpoints that is going to be for the next integer. And this is an example of a step function. And specifically, this is our greatest integer function. going to graph our own piecewise function. We are given our function that we want to graph with our specific domain. So the first thing we're going to do is make a line at where our domains are going to be ending. So we want all values less than or equal to -2. So I'm going to -2 and I'm making a line because I know there's something happening to the left of that line. Then from -2 to 0, there's something different happening. Then from greater than 0, something else will be happening. So now it's time to make table of values for each part of our domain. So I'm going to start at my fence always for my table of values. So I have x, y, and -2 is what I'm plugging in for my first line. 2 times -2 plus 6. I get -4 plus 6, which is equal to 2. So I have a point -2, 2. Since I am or equal to in my domain, I'm making a closed circle on my graph. Now I know that I have a positive slope of 2 for this function, which means I'm going to use my slope to graph the rest of these points. I'm going to go down 2 and to the left 1. Down 2 and to the left 1. Down 2 and to the left 1. Graphing the line 2x plus 6 equals y. Then for my middle part of my fence, between -2 and 0, I want to graph -2x minus 2. So I'm once again going to figure out where I'm starting on my fence at -2. So I'm plugging in -2 into my function. So -2 times -2 is 4, minus 2 is 2. Therefore, I have the point -2, 2, which is already on my graph. So that's where I'm starting. And since I have a slope of -2 over 1, I'm going to use my slope. Go down 2 to the right 1, down 2 to the right 1. And since on 0, I am or equal to 0, I am making a closed point at 0. Finally, we have our last part of our piecewise function, and we want it to be greater than 0. So once again, figure out where we're starting on our fence. I'm going to plug in 0. 3 times 0 minus 2. That means I have 0 minus 2, which is -2. That's already a point, but I'm going to start at -2. I have a slope of 3, so I'm going up 3 over 1. Up 3 over 1. And I have now graphed this piecewise function. Once again, I'm going to take away these yellow lines so that I don't get confused with them being part of my graph. They're just to help me understand where my domains are stopping. That's it for piecewise functions.